Everything a car can do, accelerate, brake, turn, funnels through 4 hand-sized patches of rubber.
On wet roads, the enemy is hydrodynamic lift. Tread blocks and sipes create edges. As the footprint enters and leaves the patch, the carcass has to flex. Radial cords let the sidewall bend with low energy.
Every layer solves a conflict. The innerliner holds air. Body plies carry tension.
Rolling resistance is rubber's hysteresis, energy turned into heat. We want less of that loss at cruise for a
cornering force comes from controlled shear in the contact patch. Belt angles and shoulder design manage how the footprint stretches sideways.
These markings aren't decoration. Load and speed ratings define tested limits. Inflation sets patch size, roughly low.
This is the outcome we're building toward. A stable, repeatable contact patch in all weather. Every factory Solution SBR and high-cis polybutadiene are built molecule by molecule. In hydrocarbon solution, an organolithium initiator.
Innerliners use butyl rubber for its tiny free vol and slow gas diffusion. The base polymer is made at low temperatures to lock in that dense chain packing. Heavy aromatic oil cracks in a high-temperature furnace to form nanocarbon. Quenching stops particle growth at a target surface area, say N220 versus N330.
Silica is born by acidifying sodium silicate. Control of pH, temperature, and aging sets particle size. Steel starts as 0.7 to 0.8% carbon rod, drawn to hair-thin filaments, heat-treated, then brass-plated a few tenths of a micron thick. Compounding is where grip, wear, and efficiency are programmed. Tight dosing and dust extraction keep batches repeatable and safe. Load cells hit within tenths of a percent. Small errors shift cure speed and hysteresis, expensive downstream. Ram pressure forces rubber into high shear to break filler clusters. We dump at a target drop temperature, the sweet spot for dispersion. Fast cooling locks in dispersion. Anti-tack stops blocking, and color stripes encode the exact compound and line. UNI sets processability. MDR verifies the cure window. RPA checks filler network. If curves drift, the line corrects before scrap appears.
Each slab carries its recipe, mixer energy, and timestamp. That data guarantees consistent tires and fast root cause analysis if anything slips.
Calendering makes rubber dimensionally precise. Servo-controlled nips and roll crown keep gauge uniform. The innerliner is the tire's air tank. Subliminal and uniform, it seals without adding mass. Release film protects tack for later building.
Roll temperatures tune viscosity and finish. Too cold, thickness wanders. Too hot, you risk scorch and poor adhesion.
Skim calendering coats and spaces cords with precise gauge. Even tension and coverage prevent weak spots and ply separations down the line. 2 compounds, 1 profile. A grippy silica-rich cap over a low hysteresis base to cut rolling resistance.
Rubber swells as it leaves the die. Lasers track geometry in grams per meter, feeding closed-loop corrections so every meter matches the CAD profile.
Rapid cooling locks shape and tack. Color stripes encode compound and line. Cut lengths and sidewalls weight, dimensionally stable for tire building.
This is where flat components become a carcass. Every axis, tension, position, splice, the innerliner seals air. A perfect butt splice prevents leak paths, and tight web tension avoids wrinkles that would trap air.
Body plies carry load. Cords are radial, 90 degrees to the circumference, so sidewalls flex while the tread stays stable. Tension is held to newtons, or the carcass will bias.
Beads clamp the rim. The plies wrap them to lock forces into steel. The hard apex smooths the stress gradient and sharpens steering response. Warm tack gives instant adhesion without scorching. Sidewalls tune ride and impact cut resistance. Chafers guard the rim seat from abrasion.
Shaping sets the final contour before belts arrive. Controlled inflation aligns ply angles and bead seating, locking in roundness. Belt angles create cornering stiffness without making the sidewall harsh. Wedge gum protects belt edges. Nylon cap controls high-speed growth.
The tread is the interface to the road. Precise splice align, thorough stitching, purge trapped air.
Curing locks shape and properties. Heat and pressure stamp the tread and build the rubber's elastic network, identically every cycle.
Even heat is everything. Zoned channels keep crown and shoulders curing at the same rate. No hard centers, no undercured edges.
The bladder presses rubber into every groove. Steam heats fast, nitrogen holds clean pressure. Two-stage inflation seats detail and avoids blisters.
Sulfur builds bridges between chains. Silane ties silica into that network.
Vents bleed trapped air so rubber can contact steel. Those little hairs are vent spews, evidence the air had a clean escape. Cure time follows Arrhenius kinetics. The controller trims seconds to hit T90, our target state of cure, every press close.
When time and torque line up, pressure bleeds off and the mold opens. The pattern you designed is now locked into rubber.
PCI cools the carcass round, reducing flat spotting. Regular dry ice cleaning keeps vents and sipes sharp. Uniform tires, shift after shift.
The load wheel measures force variation each revolution. Fewer peaks means smoother ride and less cabin buzz.
Lasers map radial and lateral runout to tenths of a millimeter. Geometry here predicts shimmy and vibration later.
We measure mass imbalance and mark it. Yellow for the light point, red for the high RFV spot. Assemblers align these to minimize added wheel weights.
X-ray verifies belt angles, splice quality, and bead seating, and catches stray metal before it reaches a road.
Under vacuum and a tiny heat step, weak interfaces breathe.
Air retention is non-negotiable. Bubble imaging or pressure decay confirms there are no microleaks through tread, bead, or liner. Machine vision spots surface defects humans miss. Quick trimming and code checks keep aesthetics and traceability tight. Every result ties back to materials, mixer batch, TBM, and press. Pass, correct, or quarantine. Data drives the gate. The load wheel measures force variation each revolution. Fewer peaks means smoother ride and less cabin buzz.
Lasers map radial and lateral runout to tenths of a millimeter. Geometry here predicts shimmy and vibration later.
We measure mass imbalance and mark it. Yellow for the light point, red for the high RFV spot. Assemblers align these to minimize added wheel weights.
X-ray verifies belt angles, splice quality, and bead seating, and catches stray metal before it reaches a road.
Under vacuum and a tiny heat step, weak interfaces breathe.
Air retention is non-negotiable. Bubble imaging or pressure decay confirms there are no microleaks through tread, bead, or liner. Machine vision spots surface defects humans miss. Quick trimming and code checks keep aesthetics and traceability tight. Every result ties back to materials, mixer batch, TBM, and press. Pass, correct, or quarantine. Data drives the gate.
A stepped multi-hour profile forces heat into the carcass. Wearproof Goody Life, belts, plies, and innerliner must.
A lateral load tries to peel the bead. Passing means the bead, apex, and chafer keep the tire locked to the rim even when pressure drops. This simulates sharp impacts and debris. We measure energy to rupture and post-impact damage, validating tread, belt skim adhesion, and
Cooling force is hysteresis. Lower RRC means less fuel burned. Silica silane chemistry and cap/base tread design pay off here.
Against a reference tire, we quantify wet grip on calibrated asphalt. Geometry plus compound tan delta at low temps decides the stopping distance.
Compound tests set the bounds. Strength, tear, hardness, hysteresis, and crack growth. If curves drift, durability on the drum will too. We section, measure, and peel to failure. Fracture surfaces and adhesion values tell us exactly where to tune Labels turn certified test data into choices. Barcodes link each tire to its ME.
Yellow marks the light point. Red marks the high force spot. Aligning these at assembly cuts wheel weights and ride shake. Passive UHF tags give contactless IDs from factory to warehouse to dealer. Instant audits without scanning every barcode.
Interlace stacks maximize density without crushing beads. Polyester strapping holds load, tight enough to ship, not enough to deform.
Tires rest cool, dark, and dry, away from ozone and sunlight. FIFO/FEFO by DOT date prevents long sits and flat spotting. Clamp pressure is sized to the tire.
Gripping sidewalls avoids tread cuts and bead distortion during moves.
A laced pattern fills volume efficiently while keeping center of mass low. Load plans hit weight limits safely and prevent cargo shift.
Uncured scrap is reworked. Cured scrap becomes crumb or feeds pyrolysis to make oil, steel, and RCB.